Hello, can you hear me?
Yes.
Excellent. Okay, so I'm going to be hosting you today. We're just going to wait for a few more minutes for others to join. Okay?
Yeah.
Okay, so whilst we wait for the others to join, I'm just going to introduce our organization and MEA. So welcome to AFBE, which stands for the Association for Black and Ethnic Minority Engineers. My name is Tolu. I'm one of the board members, and I'm going to be hosting you today for today's maths session. Like I said, we'll just wait a couple more minutes for other people who are going to be joining to join, and I'll tell you a little bit about what we do. So we're an organization basically with a platform to raise awareness for engineering role models from the Black and ethnic minority background. We run different types of activities for different sort of categories of individuals. So we run activities for school-age kids like yourself, and the theme and name for the group of programs we run for school-age kids is referred to as Making Engineering Hot in England. In Scotland, the name is Next Generation. So this kind of feeds off of one of the Making Engineering Hot programs. So through Making Engineering Hot, we've been able to inspire hundreds of school-age kids to basically become more aware of STEM, so science, technology, engineering, and mathematics. And equally, our branch in Scotland, which goes by the name Next Gen, have been able to inspire hundreds of kids as well into science, STEM, technology, engineering, and mathematics. We do lots of fun activities with school-aged kids. Activities involving robots. For example, I've worked as a mentor at a school. I did a stint there last year where we got to work on some really cool engineering projects. We built bridges. We built traffic light stations, and the idea is just to essentially give you guys the opportunity to understand what engineers do, what scientists do in their day-to-day roles. So that's a little bit about our organization. So what I'm going to do now is I'm going to load up my presentation. It's 12:30 now, so I'm just going to load up my presentation. So I'll just carry on introducing myself. So basically, now I can share my screen. I'll load up my screen. So I'm an engineer myself. I'm a chemical engineer, but I also I'm a maths tutor as well. So I really enjoy maths, and I'm super excited about sharing some of my maths knowledge with you today. So can everyone see my screen? If you can see my screen, can you just give me a thumbs up? If you can see my screen. Excellent. Okay, so just go to the first slide. Okay, so in addition to myself, we've got another mathematics expert here today by the name Titi. She is also going to be supporting me on this, on this presentation. She basically, if you have any questions at any point during the presentation, put it in the chat, and she'll either flag it up to me, or I'll pick it up myself. Just a couple of rules to kind of abide by. Generally keep your mics on mute to avoid any background noise or distraction. If you have any questions, like I said, put the question in the chat, and I'll pick it up, or Titi will pick it up. And I hope you've all got access or got a pen and paper that you can write on, because we're going to be solving mathematics together today. So if you haven't got one, you've got a few seconds to grab one right now. Yes, I will start the presentation without any further ado. Right, okay, so testing volume. My volume should be slightly better now. Okay, so we are going to be solving maths problems today, and we're going to be covering three main topics. We're going to be covering numbers, we're going to be covering algebra, and we're going to be covering shapes, right? Okay, so the way in which it's going to work is I'll cover a basic sort of theory for each aspect, for each topic. We'll then go into worked examples. Each topic has 4 worked examples, and each example has varying difficulty level. So I understand that we've got school age kids from the ages of 11 to 16 on the session today. So my expectation is that what examples 1 and 2 attempted by year 7 to 9, and examples 3 and 4, which are slightly more difficult, my expectation is that they're attempted by years 10 and 11. So those are the ones closer to the GCSE exams. Okay, so firstly, we are going to start with numbers. So we're going to be looking at place value, rounding and estimating. A lot of you are probably quite familiar with this already, but I'll just go over it again because it's one of the fundamentals of mathematics. So usually there are 2 categories of numbers. You've got whole numbers, you've got decimals. With whole numbers on the left-hand side are usually numbers that each digit in the numbers has a significance, has a value attributed to it. So for example, here we've got 3,147,286. As you can see, that's a lot of numbers, but as you can also see from the annotated diagram, each digit represents something. So for example, 6 in this number represents unit. It's just a unit, right? 8 represents tens. So 8 represents 80. So it's 8 tens. Similarly, 2 represents 100. So 200, and so on and so forth. I always advise that when you're having to do order a number or do place value, annotate from the smallest number and work your way up. One thing that also helps me is actually being able to write out the number, because you're more likely to write what it stands for. I think someone's mic is on. So can I please ask everyone to put their mic on mute again so that we don't have any distraction? Okay, so far so good. Give me a thumbs up if you're following. So far so good. Okay, excellent. Okay, so that's whole numbers, and then we've got decimals. So decimals are usually a bit more tricky because they're those numbers that have, you know, dots in them. So decimals usually represents numbers between the numbers that aren't whole numbers, essentially. And it's somewhat similar to the place value for decimals is somewhat similar. For example, as we can see, the values that come before the dot, which would be the whole number aspect of the decimal, follows the same trend as that of the whole number. So you've got your unit, you've got your 10, you've got your hundreds. However, once you pass the dots, you start seeing tenths rather than 10. You see hundredth rather than hundred, and thousandth rather than thousand. That's because number 2, for example, in this number represents a tenth. Yeah, so it's 0.2, and 0.2 is 2 times 1 over 10, so it's 2 tenths. And number 5 in this decimal number represents 500th. So that's usually the shape in which decimals take. Again, if you have any questions, please post them in the chat or unmute your mic, and I'll be able to answer them. Now we're going to be moving on to our first set of worked example. Now I want to see you guys grabbing your pens and paper. I'm going to give you 1 minute to solve this, and we're going to go through the answers together. Okay? So I want to see you writing and going, or some of you might be able to solve this mentally. So. Right, okay, so let's go to the answers. I'm going to reveal the answers, but I'm also going to go through it with us. Okay, so here goes the answers. So number 1, what does 1 represent in the number below? So do we all agree that number 1 represents 10? Yeah, I can see some nods. Cool. The number 1 represents 10 because, you know, this number, if we were to read it out, it's 5,000 917. 17 is 10 plus 7. So number 1 in this value is 10. Now we go to, we move on to question number 2. What does 7 represent? So again, the first obvious thing about this number is that it's a decimal number, right? And it's got 4 decimal points, right? 5.2718. And we've been asked to determine what 7 represents. 7 represents the 100th value. And I've got a little illustration here to explain that. So like I said in the previous slide, this is the second decimal point. So this is 0.0, it's 0.07 essentially. 0.07 is 7 times 1 over 100, so it's 100th. Okay, we move on to question number 3. Round up to the nearest 100. So the value here is 62954, which is also 62,954. Did anyone get 63,000 as the nearest 100? Yeah, I can see some nods. Yes, excellent. Okay, so 63,000 because 100, our 100 term here is 9, and that's 954. 954 lies between 900 and 1,000. Because it's 954, 54, it's great. It goes in the other direction. So you round it up rather than round it down, right? So 954 rounded up to the nearest 100 is essentially 1,000. And the nearest 1,000 to 62,954 is 63,000. So that's the answer, 63,000. And the last question, round up to the nearest whole number. So this is 66. This is another decimal number, 66 plus 66.09. So it's a fairly straightforward one, actually. The first number after the decimal point is 0, which means this cannot be rounded to the to the next number. So it still retains the form of 66. Are we all agreed that 66 is the nearest whole number? Excellent, excellent, excellent. Now we're going to be looking at another aspect of numbers. So this time we're looking at fractions, decimals, and percentages. Now, there are generally 3 types of fractions. The first is proper fractions. So proper fractions have the numerator less than the denominator. So an example here is 1 over 4, 15 divided by 20, 15 over 20, 5 over 8. These are all proper fractions because the number at the top is smaller than the number at the bottom. We then move on to another category of fractions called improper fractions. Improper fractions are slightly different to proper fractions in that the numerator is bigger than the denominator. As you can see in these examples, 29 over 15, 4 over 3, 15 over 12. Usually these numbers are greater than 1. So with proper fractions, they're generally less than 1. Typically less than 1, whereas improper fractions are greater than 1 because the top number is bigger. And then we've got mixed fractions. Mixed fractions are a combination of whole numbers and a proper fraction. So for example, here you've got 1, 2 over 3, which also translates to 5 over 3. And you've got 6, 9 over 20, 5, 1 over, so the 1 represents a whole number. This is a fraction, obviously, whole number fraction. Is that understood? Can I get some nods or thumbs up? If you probably knew that before, but it's just a way of kind of refreshing our memory as well, and refreshing our knowledge. Okay, I'm just going to look at the chat just fairly quickly because I think we might have some questions, or maybe there aren't. Okay, there aren't any questions yet. Okay, excellent. All right, okay, so we are now going to move on to our second set of word examples, which is going to be on percentages, fractions, and decimals. So, can everyone see the question? Excellent. Okay, so years 7 to 9 attempt questions 1 and 2, and years 10 to 11 attempt questions 3 to 4. So I'm going to give you again another minute to solve this, and then we can go through the answers together. And I'm actually going to go through it on the whiteboard right now, this time round. So I'm going to start counting. Okay, so let's see if we've all got the same answers. Okay, so I've got a whiteboard here, And I'm going to use that to solve it. Can everyone see my whiteboard? Can you see what I've written on the whiteboard? Yeah? Or is it too far away?
It's too far away.
Far away.
Is it
Yes, too far away.
Is it better? Can you see it now? Or is it?
Yes.
Much better. Okay, cool. All right. Okay, so the first question, which fraction is smaller? We've got 11 over 15 and 13 over 15. This is a fairly straightforward one, but usually for fractions, I always say when you're ordering fractions, it's always good to have the fractions represented as have the same denominator, so that way you can actually compare the fractions. So they both have the same denominator, so it's naturally 15. 15 divided by 15 is 1, it's 11. And this fraction is 13, and naturally the smaller number is 11. So the answer is 11 over 15. Did we all get that? Yeah, we got that, okay? And can you all see my board? Right, okay, so the second question is 16 2 over 3 minus 12 3 over 4. So can I just get a shout what kind of fractions these are before we start?
Mixed numbers.
Excellent. Well done, everyone. Well done, everyone. So the first thing is when you're subtracting or adding mixed numbers, you can. The first thing I would suggest is that you convert them to improper fractions. You can add or subtract the whole numbers as well, and we can do that in this case. But then if the fraction here is smaller than the fraction there, it can get a bit tricky. So that's why I'm suggesting we turn it into an improper fraction. So to change it into an improper fraction, the new improper fraction becomes 50 over 3, yeah? And this fraction becomes 51 over 3, okay? Sorry, 51 over 4 rather. Just to explain how I got that, 16 times 3 is 48, 48 plus 2 is 50, 50 over 3. 4 times 12 is 48, 48 plus 3 is 51. And that's how I got 51 over 4. Now, what's the lowest common multiple for these two numbers? It's 12. Yes? 3 into 12 is 4. 4 times 50 is 200. 4 into 12 is 3. 3 times 51 is 153. 200 minus 153 is 47 over 12. So now 47 over 12 is 12 will go in. You can divide 47 by 12 3 whole times, but then there's a remainder. The remainder is 12 times 3 is essentially 36, right? So 47 minus
9 over 12.
Excellent. But remember, I said simplify. With maths, it's always important for us to read the questions carefully. So 9 over...
Simplified is 3 3/4.
Excellent. That's brilliant. And that's the answer. Okay? So I'm just going to rub that out and we're going to move on to question number 3, which is a little bit more tricky. So we've got these values, 3.24, 3 1/4, 3 7 over 25, 3.27%, and 3 11 over 15. Right, okay, so we've got 5 numbers and we've got to start with the smallest number and order them in an ascending order. So ascending means increasing, okay? So we've got fractions, we've got decimals, we've got percentage. So we've got a mixture here. So the best thing to do is to make all the numbers, have them change into one type of number, essentially. So I'm going to order them by basically starting with the fractions. Now, actually, before we go with the fractions, we can simplify this number a bit more. 3.24 is 3 plus 0.24, correct? And 0.24 is 24 over 100. So that in itself, as an improper fraction, is 3/24 over 100, yeah? we're going to leave this out for the time being because that's a percentage. Just trying to open my pen. So we're gonna leave this out for the meantime because that's a percentage, okay? And we're going to pick these numbers, so we've now established that this is now 324 over 100, 3 1 over 4, 3 7 over 25, 3 11 over 50. All right. So first thing is to change them into improper fractions, right? 100 times 3 is 300 plus 24 is 324 over 100. This as an improper fraction is 13 over 4. This is an improper fraction is 25 times 3, 75 plus 7, 82 over 25. And the last number, 50 times 3 is 150 plus 11 is 161 over 50. So like I did with the first question, let's order them. So the lowest common multiple is 100, right? So that is 324. 4 into 100 is 25 times 13. 25 times 13 is, permit you to use your calculator here because I'm using mine. It's 325, okay? 325. 25 into 100 is 4. 4 times 82 is 368, I think. Let's just double check that. Yeah, 328 rather. And 50 into 100 is 2. 2 times 161 is 362, I think. Let me just check that.
Tolu.
Yep.
I think the previous question, there's a conversation in the chat room about the answer you gave.
All right, okay.
And yeah.
I will attend to that. Let's finish this question and I'll attend to that, okay? Okay, so now we've got 324, 325, 328, 322. So the smallest number is 322, right? 322 over 100. Following that is 324 over 100. Following that is 325 over 100. Following that is 328 over 100. And just going back to our fractions, 322 over 100 corresponds to 311 over 50. Yeah. 324 corresponds with 3 1/4. 328 corresponds with 3 725, and 325 should come first. So 325 corresponds with 3 1/4. 3.24, 3 1/4, 1 2 3 7 25. Okay, now the value we have here, sorry, I'm running out of space, 3.27% over 100, that's 0.0327 essentially. So that's actually our smallest number. Yeah, so the answer then becomes 327%, 311 over 50, 3.24, 3 1 over 4, 3 7 over 25. Did anyone get it in that order? I can see one hand up and possibly more. Did any of the older years get that? And would you like me to go through that?
I didn't have much time.
Oh, you didn't have much time? It was one, okay. In fairness, I've spent about 5 minutes doing it, so I should have given you a bit more answer. But do we understand the method?
Well, I didn't even do it.
Oh, you didn't really do it. Okay. So the key thing here is to always simplify the fractions. So it's difficult to compare 3 7 over 25 to 3.27%. So the most important thing when you have to order fractions is to simplify them. And that's what we spent most of the steps doing, simplifying them in a way that allows us, so basically you want them to have the same denominator, because when they have the same denominator, it's easy to tell that actually this is the biggest number. So therefore that's the biggest fraction. Yeah, is that understood? Thumbs up. Okay, so I'm just gonna go drop the board. I'm just gonna look in the chat to see what question there was. Bear with me one moment, because we don't want to lose people essentially. So we need to understand, just trying to find chat. Okay, I can see some, we did. I think the light is making the board noise not so clear. Okay, apologies about that. Other questions? I think I may have lost the questions. Nick, if you're still
I think the question was about the wrong answer. They said it was 311/12 in the previous one.
I made a mistake with
Question.
my calculation, that's why.
What did you say?
I made a mistake with my calculation. I think I made a mistake in my calculation.
Okay, all right, that's fine. That's all right. I like to be challenged. So, but do you understand how we got that answer now?
Yeah.
Excellent, excellent. Feel free to comment in the chat. Okay, so we're now going to move on to the last one. I'm just going to rub the board so that we can do the last question. And the last question reads, this is quite an interesting one. Okay, so Peter gets 10% extra time on his school exams. If the time Peter gets is 1 hour, 33 minutes, 30 seconds to complete his math exams, how long do most students get? Right, okay, so I'm going to show you how we got this answer, and I'm going to use a red pen this time round, okay, to solve it. So let's say that the time that everyone else gets is T. I'm actually introducing a concept that we're going to be treating later on, which is algebra. So let's say everyone gets T time to complete their exam, right? But Peter gets 10% of T plus T, yeah? He gets 10% extra time. So if 10% of T plus T, sorry, I need to be, my handwriting can be quite awful sometimes. 10% of T plus T is equal to 1 hour, 33 minutes and 30 seconds. Yeah? 10% is 0.1. 0.1 plus 1 is 1.1 T. Yeah? When you add 10% to a number, usually that number becomes 1.1. If you add 20% to a number, that number becomes 1.2. And it kind of goes on like that. Now we've got hour, we've got minutes, we've got seconds. So for me, it's just 3 different units of time is not the most helpful thing. So let's change it to 1 unit, right? Let's change it to seconds, because that's the smallest number. So 1 hour is 60 minutes, right? Plus 33 minutes. That's 93 minutes, yeah? 93 minutes, when you convert it to seconds, is 93 times 60, yeah? And again, I'm using my calculator. 93 times 60 is 5580 seconds. 5580 seconds plus 30 seconds is 5610 seconds. So that's not the answer. We're just trying to simplify the time in a way that we can work with. So we've now got, so 1 hour, 33 minutes, 30 seconds converted to seconds is 5610. Right? So now T is what we're trying to look for, because T is the time that everyone else gets. So a simple equation to say 1.1 T, 1.1 times T is 5610 seconds. T then therefore becomes 5610 divided by 1.1. And that's how we work out what everyone else gets. And that answer is 5,100, which again, you can convert back to seconds or minutes. Actually, we just divided by 60. That is 85 minutes on the dot, or 1 hour, 25 minutes. Yes? Is that understood? Can I get a thumbs up if that's okay? Thumbs down if you want me to go through it again. You want me to go through it? Oh, thumbs up, okay. Thumbs up. Okay. So the key thing here is just understanding how Peter's time differs to everyone else's time. So he gets 10% more. So essentially his time is 1.1 t, and t is the time of everyone else, and that's what we're trying to find. Someone said they got 1 hour 24 minutes. Holly, very close. And if I were your maths teacher, I'd probably give you 4 marks. So well done for that. Okay. All right. Now we're going to move on to, so for everyone that participated in that and got the answers, even if you didn't get the right answers, you know, well done for your attempt. I know that I haven't given you sufficient amount of time to do this, but I do hope that you, at the end of the session, can go home and can spend a bit more time on it. All right, okay, so now we're gonna go into algebra, which I slightly introduced here. So algebra is, I remember the first time I saw algebra at school, I thought, why are there letters? It's meant to be maths, and I'm meant to be seeing numbers. But you know, maths is very interesting and, you know, versatile in that we also use letters to express ourselves. So I'm just gonna cover a few basics. I'm getting the shot better. Okay, so when you see expressions involving letters such as A, B, X, Y, those letters are referred to as variables. And the reason why they're indicated as letters is because they're not known, they're unknowns, okay? So you've got examples of equations here. My arrow's kind of done something weird, but anyway. Equations are usually, you know, expressions involving letters. So for example, 2x plus 1, a minus 3 is greater than 6, and this is meant to be x squared plus 2x plus 1. These are what you would refer to as equation. Some equations have different types of variables. So some have just one variable. So for example, 2x plus 1 equals 5. So it's a one variable equation in that there's only x in this equation. You've got 2 variable type equations as well. So you've got x, y, which means you have to generally solve for x and y. And then you can get 3 variable equations as well, x plus y plus z equals 1. And I think the 3 variable is the maximum you should see at GCSE level. So we're gonna stop it there. So we're gonna move on to types of equations. So there are generally 2 I'm gonna talk about in this session. The first one is linear equations. So linear equations usually have basically, how do I explain it? So they can have 1 or 2 variables, but the key thing about linear equations is you don't see any powers associated with the variables. So for example, y equals mx plus c is a linear equation. This means that if this number here increases by 10, this number will also increase by 10. It's a linear relationship. And usually on a graph, a linear equation is expressed as a straight line. And then we've got non-linear equations. And an example of a non-linear equation that we're going to look at today is a quadratic equation. So you've got ax squared, it's got a power, plus by squared is equal to c. So this is a quadratic type of equation, which is something that you're going to come across very much in your sort of maths, you know, topics up until GCSE. Usually these graphs look like curves on the graph. So it means that the changes in c, if c increases by 10, for example, this other side of the equation does not increase by the same amount. It's not a straight line graph, yeah? There are other types of equations, cubic, quadruple, well, ones with powers of 4, which I think they're referred to as binomial expressions, or some type of binomial equation. But at this level, we're just gonna stick to the ones with the powers of 2, okay? Also, there are some algebraic principles that guide, you know, the kinds of operations and the methods that we, or the way in which we solve algebraic equations. So as a general rule, x plus y squared would normally translate to x would typically or always translate to x squared plus 2xy plus y squared. X minus y squared, this should have a squared, so apologies for that, would normally translate to the same equation, except this plus becomes negative minus, okay? And there are other rules that guide some of our operations in algebra. So with that knowledge, let's practice some algebraic questions. Again, if the years 7 to 9 can attempt questions 1 and 2, and if the years 10, and 11.
Tolu. I think Raphael has his hand up. So
Oh,
maybe-
right. Okay, Raphael. Okay, Raphael, you can unmute yourself and I can answer your question. Okay, or does he want me to unmute him? I can't quite see him.
Or maybe. Okay.
Okay. Raphael, just feel free to, when you want to speak about your question, put a message in the chat or raise your hand again. And I'll...
I don't think I did have a question. I think I pressed a button by accident.
Oh, that's all right then. That's fine. Thanks for clarifying. Okay, so as per usual, if the years 7 to 9 can solve questions 1 and 2, and the years 10 and 11, so GCSE, can solve questions 3 and 4. So I'm going to give you, let's say, 3 minutes this time round to solve it, and then we can do it together. We can solve the questions together. If you haven't finished them, don't worry, you can still carry on. It's just for those who have finished, we'll just start going through them together. Right, so the first question is, like I said in the previous slide, there are different types of operations you can carry out with algebra. Just like normal numbers, such as, you know, oh, my camera's off. Okay, I'm going to turn my camera on. Okay, so you should all be able to see me. Someone said they finished all of it. Excellent. That's really good. Okay, so we're going to be looking at different operations here. So the first one is simplifying like terms. So we've got 18 plus 9y plus 8y plus 19j plus 12, right? Okay. If I go to the answers, so you can have it on the screen. Ooh. You'll notice that in the answers, I've specifically color-coded numbers which look alike. And numbers which look alike are usually referred to as like terms. So in mathematics...
Can't see the screen.
Okay, is it better now?
No, not really. Oh, yeah,
Okay.
now, yeah.
Yeah, okay, excellent. Can everyone see the board now? Yeah?
Yes.
Okay, cool. All right, we've got another cross on the screen, so we can just refrain from doing that so people can see the questions properly. Okay, so a basic rule is that you do not add or subtract numbers that are not alike. So for example, you cannot add 18 plus 9y because they're quite similar numbers. 18 doesn't have a y in it, so therefore you cannot add it to 9y. So what we're going to do instead is we're going to add the terms which are alike. So 18 and 12 are alike. So 18 plus 12 is equal to 30. 9y and 8y is 17y. And then we've got 19j on its own. So the answer to that question is 30 plus 17y plus 19j. Yeah, did we all get that? Thumbs up if you got it. Excellent. I can see loads. Okay. I think no the screen is clear now, so you should all be able to see the answers. Okay. So we're going to move on to question 2. So question 2 is a substitution operation. So we're told to find k. Yeah. So there's an equation there that says k is equal to nm minus m minus n, right? We're also told that n is equal to 3 and m is equal to 3. So essentially, our equation becomes 3 times 3 minus 3 minus 3, 9 minus 3 minus 3. Our answer is 3. Yeah? Thumbs up if you got that. Excellent. Now for the slightly older years, it gets a little bit more complicated. So question 3 is 15x squared plus 35x over 10x. If you can't see my face, that's fine, so long as you can see the board. So the first thing to do here is to simplify the fractions, yeah? So I would write this out as 15x squared over 10x plus 35x over 10x. Yeah, that way you can start dividing and, you know, cancelling out common factors. So that should be x squared. Okay, so we can cancel that out. We can cancel this out. 5 is a common factor, so 5 will go in 15 3 times and will go in 10 2 times. The same here, 5 2 5 7. So our answer then becomes 3x over 2 plus 7 over 2. And because they're the same denominators, we can write it simply as 3x plus 7 over 2. Understood? Excellent, okay. Just see, okay, there are no questions in the chat, so I'll assume everyone's following the calculations. And now to the final question. So, the final question is x squared minus 3x over 2 divided by x squared minus 5x plus 6 over 14x, right? So the first thing we're going to do is change that into times, yeah? So x squared minus 3x over 2. If we're changing this into multiplication, we need to flip this fraction, right? So it becomes 14x divided by x squared minus 5x plus 6. So now we need to basically collect common factors, right? So we can simplify this to become x minus 3. Again, if you were to expand the bracket, x times x is x squared, x times minus 3 is minus 3x, okay? It's just always good to simplify maths, right? Okay, so times 14x. Now we have a quadratic equation here. And in order to simplify it, in order to solve this question, we need to simplify it, right? Okay, so I'm gonna take us on a journey here because we haven't actually done any quadratic equation examples. So x squared minus 5x plus 6 can also be written as x, yeah? Because x times x is x squared. If it's a minus here, it means that one of them is, and a plus here means that both are minuses because minus times minus is plus, right? We need to figure out what numbers go into this bracket, right? Okay, so a useful way of doing that is to rewrite this fraction as this equation rather, as x squared minus. Now, there are two numbers. We want to break down this number, right? There are two numbers that when you add together should give you minus 5x. So if you add minus 2x and minus 3x, it's essentially the same thing as minus 5x. So essentially, what we've done is rewritten minus 5x as two numbers. And then we've brought the plus 6 over, yeah? We can put a bracket around these two numbers. There's a question?
We can't see the board.
Can you see it better now?
Can you move it a bit to the right?
To the
Yeah,
right,
you can
okay.
see what's on the right.
Okay, is it better? Sorry, it's quite a small board.
Yes, it's better.
Okay, so I'm just gonna go through.
That's fine.
Okay, I'm gonna go through what I wrote on the right-hand side. So essentially what I'm doing here is simplifying this equation. So this is a quadratic equation. It's got a power of 2, right? So what I've done is I've rewritten it as x squared minus 2x minus 3x, because minus 2x and minus 3x is the same thing as minus 5x, right? So I've just broken down that number and I've added plus 6. Because by writing it that way, it allows us to be able to find the common factors. So if I put a bracket around these numbers, so it's x minus 2 minus 3x minus 2. And how did I get that? If we bring x out of the bracket, this becomes x, this becomes 2. X times x is x squared, x times 2 is minus 2x. So it's still the same number, I've just simplified it. In the same vein, the common factor here is minus 3. So if you take minus 3 out, this becomes x, and this becomes 2. So minus 3 times x is minus 3x. Minus 3 times minus 2 is plus 6. So these are the same numbers. So basically, our equation becomes x minus 2. It's a common number, and x minus 3. So essentially, this equation becomes that. Okay, we're nearly there. So going back to the main question. Okay, let me write that down a bit lower. X into x minus 3.
Please, could you move it to the right?
Yeah. So we're no longer solving. So we've basically simplified the fraction on the right. So the right hand side was just a slight digression. Okay. We've now come back to the main question, right? So remember, x minus 3 over 3 times 14, x minus 3, x minus 2. We've now solved this quadratic equation and simplified it into this equation. So now we can start cancelling.
Can you repeat the last?
Sorry, Tolu. Yeah, I think someone wanted you to go through the last part.
So the quadratic equation.
Yes.
Okay.
Raymond, sorry. Yeah, Raymond.
Raymond, you'd like me to go through the quadratic equation?
Yes, please.
Okay. What I'm going to do is I'm going to rub out the right-hand side and I'm going to start again. So let's hold this thought for 1 minute and then we're just going to solve the quadratic equation again. So the quadratic equation, which is this, is x squared minus 5x plus 6, right? X squared indicates that so x times x is x squared, essentially. A quadratic equation would usually have 2 factors, yeah? And both usually start with x's. That's usually quite easy to figure out because you know that when you times x and x is x squared. It's usually the numbers here that you need to spend a bit more time solving, right? Okay, but what I've done is I've used this number to help us. So I've rewritten the equation as x squared minus, what 2 numbers can you add together to give you minus 5x? Minus 2x and minus 3x. It's still the same equation, I've just written it in a different way. I've essentially simplified it, right? So now we can start collecting like terms. Yeah, so the like term here is x. Can everyone see me? We can't see how you're solving the question. Please show your writing. Okay, sorry, my handwriting is, I will improve on my handwriting. But are we, Raymond, are you following and everyone else?
Yeah.
Okay, okay.
Yes.
Okay, excellent. I'm collecting like terms now. So I've simplified the equation. I've now written it as x squared minus 2x minus 3x plus 6. The next step is to collect like terms. The like term in this, for this bit, is x. So I've rewritten it as x, bracket open, x minus 2. And the like term here is minus 3, which then gives us x minus 2. Minus 3 times x is minus 3x. Minus 3 times minus 2 is plus 6. Again, it's the same equation. Each step is just simplifying it further. Now we have the same numbers here. So we take one of them, x minus 2, and the other common factor is x minus 3, this and this. And that's how we get from here to here. And that's how we simplify a quadratic equation. So we can then take these numbers and put them here in place of this quadratic equation, because that then allows us to simplify our fractions. So if I just rub out my handwriting so I can write a bit more legibly, x minus 3, x minus 2. Yeah, we've got x minus 3 at the top, so we can cancel these out. Yeah, so we now have x times 14 is 14x. 3 x minus 2. For some reason, I changed 2 to 3, so pardon me. So yeah, 2, yeah? 2x minus 2. So 2 divided by 14 is 7x over x minus 2. And that's how we get to final answer. I do appreciate that this is not the most straightforward question, but again, it boils down to simplifying and just being able to break down, okay? Would you like me to go through this again? So Titi's just said in the chat that you cancel out x minus 3 because it's common. Yeah? Are we happy to carry on and move on to the next topic?
Yes. Yeah.
If you do have any burning questions at the end, you can always put a message in the chat. But yeah, I'll move on to the next topic.
Sorry, just another tip for anyone who's having issues. I think you can make, if you can make Tolu's screen bigger than the actual, you know, the actual screen that is being shared, that could probably help as well, so that you can see it brighter. Someone's just giving that advice as well in the chat. Yeah.
I think if you double click on it or press it a couple of times, it should expand the whiteboard. Okay, excellent. So well done, everyone. I thought you all engaged really well with that. So we're now going to move on swiftly to the next topic, which is the final topic for this afternoon. And the topic is triangles. So again, as I normally do, I'll start with a bit of some basic theory, and then we're going to go into doing some work examples. So you might be familiar with some of these triangles already, but we're just going to refresh our memories. So there are different types of triangles. The first one is an equilateral triangle. A key to remembering this is EQU, equal, you could say it's equal, means that all the sides are equal and all the angles are equal. So that means that this side is equal to this side is equal to this side. Essentially, you know that strike through you're seeing there on the angles usually indicates when the sides are equal. So if you can see on all sides, it means that they're all equal. Equally, the angles are equal. So 60, 60, 60. And we all know that the sum of angles in a triangle is 180 degrees. So 60 plus 60 plus 60 is 180. We now move on to isosceles triangle. So isosceles triangle differ from equilateral triangle in the sense that only two sides are equal. So as you can see, the sides that are equal are the ones with the strike through on them. So this one and this one. So it means that if this angle is 75, this angle, or if this side, for example, is 75 centimeter, it means that this side is also going to be 75 centimeter. If this angle is 75 degrees, it means that this angle is also going to be 75 degrees. So you have two equal sides and two equal angles in an isosceles triangle. The third triangle we're looking at is a scalene triangle. And as you can see from the drawing, none of the sides are equal. So yeah, and there are no strike throughs, which indicates that, yeah, the lengths are not equal either. So this could be 70, that could be 40, and that could be, you know, 70 again. Or actually, it won't be 70. It'll be, none of the sides will be equal, will have the same values. Okay? Was that a question we had there? All right, okay. Just before I carry on to the last triangle, we are officially sort of nearing our official finish time, which is 1:30. We do still have 4 questions to go through, so please feel free to stay on to go through those questions. It should take us no longer than 10 to 15 minutes. But yeah, it's just to say that we did put on the flyer 12:30 to 1:30, but we're running slightly over. So feel free to stay on. Okay, and the last triangle is a right angle. So a right angle differs from all these triangles in that the sum of the angle is 90 degrees, and that's indicated by that symbol. Whenever you see that symbol, that means 90 degrees. So take a note of that. And the right angle triangle basically is the precedent for a very well-known theory in mathematics called the Pythagoras Theorem. Has anyone here heard of the Pythagoras Theorem?
Yeah.
Yes.
Okay.
Yes, me.
If you haven't heard about it, it's okay.
Yes.
Pythagoras theorem.
Excellent. Okay, so if you haven't gone through it, it's fine. We're going to go through it today. So basically, the precedence for the Pythagoras theorem is based upon the right angle. Okay, so the Pythagoras theorem is a formula we use to calculate the sides of a right angle triangle. Yep.
Yeah.
The largest side or the longest side of a right angle triangle is usually referred to as the hypotenuse. Yeah. So C on this diagram is the hypotenuse. The side that faces or that is opposite the hypotenuse is called the opposite side. So that's A. And the last side, which is next to the hypotenuse, is referred to as the adjacent side, right? There is a well-known equation that links all three of these sides. And the equation is C squared, which is the hypotenuse squared, is equal to the square of the opposite side and the adjacent side. You just have to remember that formula, and that is essentially the Pythagoras theorem. Okay, so with that understanding, let's do some questions to practice our triangle and right angle knowledge. Okay, can everyone see the screen clearly and the numbers on the screen? Okay, so as per usual, year 7 to 9 attempts questions 1 and 2. Years 10 and 11 attempts questions 3 and 4. This number here is 77 degrees. This is X degrees, which is what we're looking for, and this is 74 degrees. This number here is 142 degrees. This is X degree, and this is 122 degrees. And I think you should be able to see those ones clearly. So I'm going to give you 5 minutes to solve this, and then we can quickly go through it on the board. Okay, I can see that a few people have done, and I appreciate that some of you might still be carrying on, but we're just going to start going through the questions together as we're quite limited on time. Okay, so the first question is based upon the Pythagoras theorem. So again, if A is 5 centimeters and B is 7 centimeters, find the length of C. So as explained in the previous slide, C is the hypotenuse here, right? And the opposite side here to the hypotenuse is B, okay? And the adjacent side is A, right? So we know that A is equal to 5, and we know that B is equal to 7, so we need to find C. I remember the Pythagoras theorem is C squared plus B squared plus 9 squared. C squared is equal to B squared plus A squared rather. Okay, so we just plug in the numbers. B squared is 7 squared, A squared is 5 squared. So C squared is 49 plus 25. 49 plus 25 is 74. C squared is equal to 74, but that's not the simplest form of our answer. We were asked to find C, not C squared. So essentially, in order to cancel out this squared, we basically apply a square root, because if we apply a square root to both sides, that cancels out the power, and then C becomes the square root of 74. Again, the square root of 74 is not necessarily the simplest form. If you are using a calculator, then you can plug this into your calculator, and that should give you about 8.6, I think. But yeah, that should be sufficient. So if you got those answers, well done. And if you didn't, hopefully you've understood how to approach it at another time, at a different time. So we're going to move on swiftly to the second question. So here we've got a triangle, and we've been asked to, can someone tell me what kind of triangle that is? Is that an equilateral triangle or isosceles or scalene? What type of triangle is it?
Scalene.
Excellent, excellent.
Scalene.
Excellent, well done. So that's X degrees. This is 77 degrees, and this is 74 degrees. So this is fairly straightforward. The total sum in this triangle, so X plus 77 plus 74 should give us 180. So essentially, x is equal to 180, and I'm bringing these values over, meaning that the signs will change, is minus 77 minus 74, and that should give us 29, I believe. Did we all get 29?
Yes.
Excellent.
Of
Well
course I did.
Of course you did. Well done. Now moving on to question 3, somewhat similar to question 2, but there's a slight trick to this one because we've got exterior angles here as well. So we start with a straight line and we've got a triangle. Yeah. So we're told to find x degrees. We don't know what this is. We don't know what this is, but we know that this is 122 degrees. And we know that this exterior angle here is 142 degrees, right? General principle rule in maths is the angle on a straight line, this angle is 180 degrees, right? This is a straight line, right? So if this angle here is 122, this angle here is going to be 180 minus 122 degrees, which is 52 degrees, okay? And equally with this side, if this angle is 142 degrees, this angle will be 180 minus 142 degree, which becomes...
It's 58.
It's 58 degrees.
Yes, thank you for correcting me, 58. See, I've got so used to using calculators that I make this slight mistakes. Well done for correcting me. And the value here is 180 minus 142 is 38 degrees.
58.
So this, we're not on the other side. So this is 58 and this is 38.
It's
Okay.
58.
38.
Excellent. So now we can find the number, this angle, because we know our interior angle. So essentially it's x plus 38 degrees plus 58 degrees is equal to 180 degrees. So x is equal to 180. I bring the values over, so the signs change from positive to negative. And our answer is, can we have a...
84 degrees.
44.
84.
Is it 54 or 44?
54.
84.
44.
Oh, 84, yeah.
84.
84.
84.
Excellent. So it's 84.
84.
Yeah. Give yourselves a round of applause.
I didn't watch it properly. I didn't look at it properly.
Oh, you didn't look at it properly. So, but do you know how we arrived at it?
I did it properly.
Okay, that's fine. But you know the method, and that's the most important thing. So if you were to do it again. So now we've been asked to write an equation. So this is question number 4. 8x degree, 10x degree, and 12x degree. So the first question is write an equation. So what equation can we write to link all 3 of these numbers? Well, we know that this plus this should give us 180. So our equation therefore is 8x degrees plus 12x degrees plus 10x is equal to 180. Remember, we went through this. An equation is basically an expression showing numbers and variables. So we've got our x's. So we are now asked to use this equation to solve for x. Well, are these like terms or they're not like terms? Are these like terms? These 3 values?
Yes, they are.
Yes, they are, because they all have x's in them, which means we can add all of them. So 8x plus 12x is 20x, 20x plus 10x is 30x. 30x degree is equal to 180. Well, if we divide both sides by 30, we can work out x degree to be 6. So x is 6. Excellent. Thank you, MTT, for that. You can also see the working out on the group. Yes, is that understood? Excellent, excellent. So I'm going excellent. So I'm going to put the board aside, and that basically marks the completion of our work. So well done, everyone, for engaging. I think you've been a brilliant audience.
Thank you.
There is just before you go, there are a couple of things. There's just a few more minutes that we need to spend.
Thank you.
There was a question here which I just need to correct. If I can find it. There was a question. So this question, when I solved it on the board, I think I said it was 3/7/12. The answer is actually 3/11/12. So it was the one where we have 47 divided by 3. So 36 divided by 3 is 12, basically. So it's 12. And the remainder, 47 minus 36.
We can't see the screen.
Okay. Can you see it now?
Yes.
This fraction, when I solved it earlier, I think I wrote the answer as 3/7/12. I'm just saying the 47/3 as a mixed fraction is 3/11/12. So that's correct. So if you got that answer, you're right. That was just an error on my side. Okay. Right. Okay. Now, so we've covered algebra, we've covered numbers, we've covered triangles, and I really hope that you've enjoyed it. Just one final thing that I'd like to share with you. This is something my teacher taught me in primary school. So I thought, you know, why not share with you guys? And when I showed it to my work colleagues, they were quite amazed by it. So it's a fun, interesting fact about the number 11. So 11 multiplied by any number can be solved by basically arranging and adding the digits in the number. So you might think, oh, what's she talking about? If we look at this example, 11 times 12, right? So if we bring 12 over here, if we write 1, we bring out 1. 1 is the first digit. You start by writing the first digit. You start by, and then next you write the last digit, 2. If you add the numbers, if you add 1 and 2, it gives you the number in the middle. So I'm just going to go through that again. So 11 times 12, if we bring 12 over here, right? To work this number out, or to work this number out without having to use a calculator, if you write the first digit, so if you times 11 by any number, the first digit of the answer will always be the first digit of the number that you're multiplying it by, as I've illustrated here. So here, the first digit is 1, you bring it over here, and then you add 1 and 2 to give you 3, and then you write down the last number, and the answer becomes 132. We see the same thing happen here. So for example, 11 times 2, 53. So again, if you had to do this mentally, if you bring 2, which is the first digit, you write it out first, and then you add the numbers. So 2 plus 5, 5 plus 3, and then 3. The answer you get is 2783. Okay, I can see someone's put their hand up. Would you like to say something? Okay, I'll take it as a mistake. Okay, so essentially the first and last numbers, and then you add the numbers to give you the numbers in the middle. And I'm just going to do this final example for you so you can see this fact a bit honed in. So 11 times 4072. So I don't have a calculator, but I've got to do this in my, carry out this calculation mentally. So again, you write out the first number, which is 4, and then you start adding the numbers. You add consecutive numbers. So the first set of numbers we're adding is 4 plus 0, which you've seen I've written here. And the second set of numbers we add is 0 plus 7, which you can see I've written here. And the last set of numbers you add is 7 plus 2, which you can see I've written here. And the last number is 2. So the first and the last number will always start and end the number sequence. And as you can see, our answer is 44792. You can double check that on a calculator. But yeah, I just thought I'd share with you guys. Holly has a question. So Holly, you can unmute yourself and ask the question.
Oh, I don't have a question.
All right, okay, fair enough. So guys, practice this 11 trick. Just write out any number and just practice it. and you'll see that it's actually quite a fun thing to do. Now, I'm just going to give you a few useful tips and resources before we leave. I think you're all brilliant at maths. The fact that you've even come to this session shows that, you know, you're very interested in it. And if you're interested in it, you have the ability to excel in it. So I would say, you know, the more practice, the better you get. That's the principle of maths. Maths is quite unique and different to other subjects in that the more time you put in, the more practice you do, the better you get. If you consider yourself to be someone who isn't naturally good at maths, I would suggest maybe if your teacher gives you 20 questions to practice as homework, maybe do another 20. It feeds into this principle. The more questions you do, the better you get at it. There's no two way about it. The second tip I'd like to give you is read your questions carefully. With maths, there are usually terms that you have to pay attention to, such as simplify, or, you know, write an equation, or write your answer to 2 decimal points or 3 decimal points. So make sure you take note of some of these things. If you noticed in my questions, I underlined some of these terms, but you know, in reality, these things won't be underlined for you. So make sure you pay attention to them. Also, it's important that you show your full method. So show your working out in tests and exams. Sometimes if the number of marks allocated to a question is 7, even if you don't get the right answer, but if you've shown you're working out, you could get 6 out of 7 marks. So that's very important. And the last thing, which I think is a tip I need to take on myself, is to write legibly. You know, we deal with a lot of numbers in mathematics, and I think sometimes, you know, when your teachers are reading your papers, they can get the numbers mixed up. I know sometimes I get even my own numbers mixed up. So make sure you form the habit of writing out legibly so that your teacher, when marking your paper, doesn't mistake or misconstrue the answer that you're given. And then here are some resources that I find useful. These is basically, Blue Tick has a lot of practice questions that you can do, and they have it at varying levels of difficulty as well. It's free to use. I Practice Math, it's free to use as well. And then you've got BBC Bite Size.
Bite Size?
Yeah, Bite Size is a really good one. My Math is also a really good one, but it requires subscription. And then you've got YouTube. So YouTube is quite a good one because it's video, so you can see some of the questions solved. Okay. And finally, thank you very much for coming along. We are happy to, you know, that you came along, and I hope you learned something new. If you'd like to contact us, that's our email. We also have Instagram accounts and Twitter accounts. Yeah, feel free to follow us and keep up to date with, you know, exciting engineering and STEM news. Finally, we have another session holding next Saturday, and that's been organised by our Scotland branch. It's called Achieving Your Dreams. It's about, you know, the steps and the attitudes that you need to imbibe to, you know, achieving your dreams. So if you are available, make sure you sign up to it. The event details are on the website, and it's holding at the same time, 12:30 to 1:30. Once again, you've been a brilliant audience. Thank you very much for coming along, and hope to see you soon. Take care and enjoy the rest of your holidays, or school term rather. Thank you.